This is the summary for Unit 3, Linear Relationships, and Lesson 3, Representing Proportional Relationships. Now, proportional means that it goes through the origin of the graph, 0, 0. So in this case, this is talking about potatoes and carrots. And there are 4 representations that we've been using. One is a verbal representation, just a description of the problem verbally. The second is a graph of that situation. The third is the table, and the fourth is the equation. So in this case, so there are always 2 properties. In this case, one property is the number of carrots, and the second property is the number of potatoes. And it's the potatoes that are going into the thought, the equation, in this case, the graph. So you have so many potatoes, how many carrots do you need? That makes the potatoes the x along the x-axis. That's what you're given, and you're going to calculate the number of carrots. So that's the answer to the question. How many carrots do you need? And you should remember by now that there's a slope triangle. That slope triangle is right against the origin because it's a proportional relationship. That makes writing the equation much easier. There's no y minus or no y plus anything, x minus anything, x plus anything. It's just y to x, the ratio of the number of units in the vertical direction to the number of units in the horizontal direction. In this case, that ratio is 3 to 2, or 3 halves. So the number of carrots that you need is 3 halves times the number of potatoes that you have. And so you start to write the equation based on that information, and you just say it. The number of carrots are 3 halves the number of potatoes. So the number of carrots, which is the value along the vertical, in the vertical direction, the y-axis, is 3 halves the number of potatoes that you have, which is the value along the x-axis or in the horizontal direction. So you just read this way: the number of carrots, y, is 3 halves times the number of potatoes. So the number of carrots, which is y, is 3 halves the number of potatoes. And again, I've said this before, you're going to learn algebraically how to move these values around, but right now you can just use the language to understand what's going on. You just look at this length. It is 3 halves the length of along the horizontal direction. This is 1 half, 2 halves, and another unit is 3 halves. So in this case, you, depending on the situation, you might use a different representation to figure out the number of carrots. In this case, you might use the equation. I have 150 potatoes. How many carrots do I need? That's 3 halves times 150. And mentally in your head, you know that half of 150 is 75. So 1 half is 75. 2 halves is 150. And 3 halves is another 75. You put that all together, it equals 225 carrots. So the number of carrots is 1.5 times the number of potatoes, which equals 225. So I am purposely switching back and forth between the decimal value, 1 5/10, and the fraction, 3 halves, to get you used to thinking of it both ways. Actually, the fraction, as you go through later math courses, the fraction is going to be much more useful to you. It's going to be much more accurate in your calculations. But let's say that the representation, the most useful representation, is a graph. So let's say that you have a restaurant and they make different size batches of stew throughout the day, and up to 300 potatoes. So the maximum size that they make is using 300 potatoes. And so how many carrots is that? So you read up the graph. You start at 300 potatoes and you read up this graph, and that tells you that the number of carrots you need is 450 carrots. So the vertical direction is 450 to the horizontal direction, which is 300. That simplifies to this 3 halves right here. So it's 150, 150, that's 300, and another 150, that's 450, that's 3 halves. So 3 halves of 300 is equal to 450. So the scale is the y-axis is the vertical direction. It's going to be the carrots, and it's labeled right here. This is the scale. The numbers along these lines is the scale. The number along these lines is the scale as well. So this is the horizontal direction, is the x-axis. So you can use the equation actually to start building the graph. So you're going to make this graph for your employees to use depending on the number of potatoes they have. So let's say now that they have actually a couple other points that you place on the graph. You use 100, that tells you it's 150 carrots. So you place a point right here. You go to 200, that tells you it's 300 carrots. This is a nice one to look at the halves. Half of 200 is 100. 2 halves of 200 is 200. And 3 halves of 200 is another 100, which is 300. So you place those points, you draw the line, and now you can use it. Let's say that you have to make a batch of stew that uses 125 potatoes. So you go here to 125, you read up to the graph, then you read over to the left to the y-axis. That tells you it's about 190 carrots. Now you don't have to be exact in this case. If you use 2 carrots too many or 2 carrots too few, it's not going to change the taste of the stew. It's only if you use 25 carrots too many or 25 carrots too few that it begins to change the taste. So a couple of carrots plus or minus 190 carrots is not going to make a difference. So you don't have to be exact in this case. All right, let's say that you get batches of potatoes in 150 potatoes per bag. So you get a bag of potatoes in. How many carrots do you need to make that batch of stew? You need 225 carrots. 225 divided by 150 is 1.5, 3 halves. So 3 halves times 150 is equal to 225 carrots. Let's say that you have 2 bags of potatoes. Then you would need 450 carrots. So this table is going to tell you how many carrots you need depending on how many potatoes. And actually, this is the number of bags. 1 bag, 2 bags, 3 bags, 4 bags. So you could actually get rid of the number of potatoes and just say 1 bag, you need 225 carrots. 2 bags, you need 450 carrots. So in that case, the concept of proportionality would be 225 times the number of bags. 2 bags times 225, 3 bags times 225, and 4 bags times 225. But they don't do that. They keep it at the number of potatoes. And you can check to make sure it's a proportional relationship by calculating the constant of proportionality all the way down. And it has to be. If it's proportional, it has to be the same. That's why it's called a constant of proportionality. So you purchase potatoes in bags of 150, use 1, 2, 3, or 4 bags. The input, what's going into your problem, what's known is the number of potatoes, the number of bags in this case, and the output, what you're going to calculate, is the number of carrots. That's the answer to the question. So you put it all together, you have a constant of proportionality. That's the change in the vertical direction compared to the change in the horizontal direction. That's always the same in a proportion. That's the rate of change. How much does it change? For an amount of potatoes, it always changes by 3 halves, or 1 5/10, or 1.5. So how much carrots, or how many carrots, change for each potato? You're always multiplying by 3.5. So the number of carrots you need is 3 halves, not 3.5, but 3 halves. The number of carrots you need is 3 halves the number of potatoes. And hopefully you would just picture this in your head. Gives me a proportional relationship. You're going to get rid of the slope triangle mentally pretty soon. And you're just going to realize that the vertical direction is 3 halves of the horizontal direction. So in this case, it's 3 units. There's 3 carrots for every 2 potatoes. That's the same as 1.5 carrots for every potato. That would be the unit rate. So here's the unit, 1 potato right here. And how many carrots you need? 1.5 carrots. That is the unit rate, which is the same as the constant of proportionality, which, by the way, is the same as the slope. So those three numbers get folded into the same number in a proportional relationship. So the equation, the graph, and the table. And you're probably starting out with the description. This is what we have in the restaurant. So I want you to put together an equation. I want you to put together a graph. I want you to put together a table. All right. Representations, proportional relationships.